Hello pre-calculus students and seekers of general truths. In this video, we will prove this sum of powers of 2's using mathematical induction. So we're trying to show that 2 to the 0 plus 2 to the first plus 2 to the second all the way on up will be equal to 2 to the n minus 1. Okay? And remember that n here is the exponent. So that's going to be something that will come in handy a little bit later. Okay, so let's start with the base case. All right, on the left-hand side, we would just have 2 to the 1 minus 1. Okay, and on the right-hand side, it's saying that we have 2 to the 1 and then minus 1. So there's a minus 1 in the exponent on the left-hand side. That's the explicit formula right here. And then there's a kind of a big 1 or an actual base of 1 on the right-hand side. Well, this turns out to be 2 to the 0th power, which is just equal to 1. And then on the right-hand side, it's 2 minus 1, which is also equal to 1. So the left-hand side and the right-hand side are equal, and this is good. Okay? Now, let us move on to the inductive case then. And we want to assume that this statement is true for, we want to show that if the statement is true for n equals k, it is also true for n equals k plus 1. So it's true for n equals k, assuming that it's already true for it's true for n equals k plus 1, assuming that it's already true for n equals k. All right. Now, so let's list this out. On the left-hand side, what do we have? We have 1 plus 2 plus 2 squared plus onwards and onwards until we get to 2 to the k minus 1. And then we're going to go one step further, 2 to the k plus 1 minus 1, or just 2 to the k. We want to show that this is equal to the right-hand side, which would be 2 to the k plus 1 in the exponent minus 1. Okay. So I'm going to continue working at this problem from the left-hand side here. Now the left-hand side is, again, we're going to use the inductive hypothesis or the inductive assumption that up to this point, this is equal to 2 to the k minus 1. Okay. And then we're still going to add 2 to the k to that. And we want to show that this expression is somehow equal to this expression on the right-hand side. Now, it's not too difficult to do once we've already made it to this point. Notice here that we have 2 of these, 2 to the k, so it's like these two expressions right here, 2 to the k plus 2 to the k, is really 2 times 2 to the k, and then we have that minus 1. So 2 times 2 to the k, well, this is just 2 to the first times 2 to the k, so this is equal to 2 to the k plus 1 minus 1, which is in fact equal to the right-hand side. So now we've shown that the base case is true, the inductive case is true, so the whole thing must be true. As always, thank you for watching, keep working hard, and have a wonderful day.